Hi everybody and thank you for joining my talk. I'm Farnaz from AIMS Group at Emory and today's talk is about crowdsourcing under data poisoning attack. This talk will be divided into 4 parts. I'm going to go through starting with defining the problem we are trying to solve here, then I'll talk about related works and we will uncover what the challenge is. In the third part, I'm going to talk about the framework used for this study, and then we'll discuss the experiments, show more some result, and talk about the future works. Let's start with crowdsourcing that can be described in a way that distributes tasks among multiple individuals to interact with their intelligence. Amazon Mechanical Turk and Vaidy are the most well-known crowdsourcing marketplaces. They aggregate the wisdom of crowd to complete a task. Sentiment analysis and transcription are the example of Mechanical Turk. For example, in a sentiment analysis, they wanted to understand the conversation. Is it the positive conversation or the negative one? An example of ways is that user can report the traffic status at various locations or pothole existence in the road. Crowdsourcing seems to be efficient and useful. However, it may be subject to data poisoning attack, where malicious users may intentionally and strategically manipulate reports to mislead the system to infer the wrong truths for all or a targeted set of tasks. Also, studies have shown that the revenue comes with a data poisoning attack to increase the sell out of the restaurant at the Yelp application. It seems worth to spend money for creating fake reviews by malicious workers. The study shows that increasing a 1-star rating on Yelp leads to increase the revenue up to 9%. Crowdsourcing systems can have this challenge to find out which truth inference performs better under adversarial setting. Now I'm going to touch on truth inference methods in the existing work and walk through different entity and modeling in crowdsourcing. Given answer set C in here that's provided by set of workers that's assigned to some of the tasks, the truth inference method aggregates those answers and determine the inferred truth answer based on the answers provided by workers for each task. Task, worker, and inference methods are entities of crowdsourcing. The task and crowdsourcing system can be categorized into decision-making tasks where workers select a binary answer such as yes or no, single label task where workers select a single label among multiple candidate labels, and numerical task where workers provide answers with numeric values. The truth inference methods may consider different factors such as type of task, difficulty level of tasks, and also the truth inference can model the behavior of workers differently. And for modeling that, they can use just a single value as the probability or use the confusion matrix. Truth inference method can be categorized into direct computation, optimization-based, probabilistic graphical model, and neural network-based. The direct computation, it aggregates workers' answers by majority voting, while treat workers equally or heuristically assigning weights to them. The optimization one, they treat the estimated labels and worker reliability as unknown and use an optimization approach to find them. The PGM-based method is explicitly model workers' reliability to estimate the labels, and for the neural network, they input the answer set to the neural network, and as output in a representation level, they get the inferred level of the task. Okay, so as I said before, the optimization-based method, they formulate the truth inference method as the optimization problem and try to solve the labels and the workers' reliability values. The existing works different in formulation of their optimization problem and objective. PM method is one of the optimization-based model that assign reliability to workers based on the distance between the inferred truth and the answers provided by workers. If that distance is smaller, it means that the worker is more reliable. That's a general probabilistic graphical model. So PGM-based method represent the true label, the worker answer, and worker's reliability as probabilistic variable and model their dependency. So in this figure, the observed variable C, that's the answer set, it depends on two variables, the reliability of the workers and the true label of the task. The two boxes of M and N indicate that there are M and N reported variables for each task and worker, and additional variable may be included, such as A and B to represent the prior distribution for the worker reliability and ground truth. Also, there are a few methods based on the neural network base that one of them use the variation autoencoder for aggregate the labels, and they input the task vector by apply the one-hot encoding on it, and they try to build the reconstruction vector of the input vectors, and in the middle layer, they wanted to infer the labels. So, till now, we just covered the existing truth inference method. Also, there is a survey that's focused on non-adversarial setting where workers may have varying reliability but don't intentionally or strategically manipulate the answers. But there isn't other works that go and to see that, okay, which one of these methods work better under adversarial settings. So after understanding the problem and the related work, I'm going to go through starting with choosing the state-of-art truth inference method and talk about the attack framework. Our goal is to be comprehensive and represent each category of techniques and worker model applicable to shed light on their role in the robustness of inference method under data poisoning attacks. When possible, we leverage the finding from the previous study by selecting the best performing methods. For direct computation, we include majority voting as a baseline and its enhanced version, majority voting with soft penalty. In optimization-based approach, we including majority voting with hard penalty, which employ a semi-matching optimization for worker task bipartite graph, and PM, which formulate the optimization problem based on infer label and worker reliability. For PGM-based method, we include the best performing DS and BCC using the confusion matrix as a worker reliability model and KOS with a single worker reliability parameter. Among neural network based, we include LAES since it's the only one applicable to a non-complete bipartite graph. Here we are talking about attack taxonomy. Attacks can be classified based on the goal into untargeted and targeted attacks. In untargeted attacks, adversaries aim to decrease the overall accuracy of crowdsourcing system, and system infer the wrong label for as many tasks as possible. In targeted attacks, malicious workers aim to decrease the accuracy of the crowdsourcing system only on targeted subset of tasks. We can classify the attacks based on the level of malicious workers' knowledge. In black box attack, the malicious workers only have access to their assigned tasks and have no other knowledge about the system. In white box attacks, the malicious workers have the full knowledge of the true inference method used and other workers' answer, allowing them to design stronger attacks. And in gray box attacks, the malicious workers may have partial knowledge, for example, partial set of another worker's answer. And attack strategy, we can classify attacks into heuristic-based and optimization-based attack that we are going to talk about it in details in further slides. Heuristic-based attack design based on black box knowledge. That means they just have knowledge to assign tasks. With only knowledge of the assigned tasks, the simplest heuristic for attacker is to always report the wrong answer for their task. However, this may be easily detected by most truth inference systems with workers' reliability modeling. Therefore, attackers desire to disguise themselves as honest workers by providing correct answer to some tasks to avoid detection. To model such behavior, each malicious worker is associated with two confusion metrics and one disguise parameter. One of the confusion metrics it's called malicious confusion metrics with two parameters, alpha prime and beta prime, and the other one is normal confusion metrics with alpha and beta parameter. Each malicious worker behaves as a normal worker modeled by normal confusion metrics with a disguised probability, and they behave as a malicious worker that modeled by malicious confusion metrics with 1 minus disguise probability. For targeted attacks, the malicious workers flip the labels for the targeted task while acting truthfully for other tasks. Optimization attack is designed for white box attack, in which attackers have full knowledge of all answers and the inference method used. The optimization aims to maximize the number of inferred labels that are flipped from before and after attack, while also maximize the inferred reliability of the attackers by the truth inference method. Intuitively, this helps them to obfuscate their malicious nature and therefore success in misleading the system. The optimization is formulated as this, where control the trade-off between the objective of maximizing the collective reliability of malicious workers and the number of flipped labels. For targeted attack, the aim is to maximize the number of targeted tasks whose label is flipped, so the optimization is just applied on targeted set. Now let's look into the experiment and the results. We use two datasets of binary task and a synthetic dataset with varying parameters for the evaluation. The dataset's properties are summarized in this table as it's shown. The number of worker tasks, ratio of label, 0 are different across datasets. Also, when you look at the redundancy, that means that the mean number of answer per task It's kind of different per dataset. And it's shown that the post-send dataset are more redundant. The other specific of datasets are called engagement. That means the average number of answers per worker. And that's different among the datasets. Also, as it's shown, the product dataset, it's more skewness in compared with the post-send and synthetic dataset. And all of the datasets, the quality of normal workers are around 80% or much higher than that. The metric that we are chosen for this evaluation are listed here. Accuracy is the fraction of correctly inferred task. The other one is called accuracy targeted, that's used for targeted attack, and it's the fraction of the targeted task whose truths are inferred correctly. The other one is called AUC, or area under the curve. Since the inference method's accuracy change over parameters, we use AUC to compare the global parameter and the performance of the methods. The other one is the recognizability. To assess the adversary detection ability of inference methods, we define recognizability as the similarity between the simulated worker reliability and the inferred reliability. It means that a higher recognizability means the method is better at detecting malicious worker. In untargeted heuristic-based attack, by increasing the number of malicious workers, the accuracy for all methods is dropped in both product dataset and post-send dataset. As it's shown, PGM methods such as DS, BCC, and KOS, and the probabilistic methods such as PM are more resistant, especially with few adversaries. The table shows the AUC of different methods over two intervals. The intervals of 0 to 30% of malicious workers as a realistic attack setting, and the interval of 0 to 50% for more aggressive attacks. Overall, DS and LAS are most resilient for this attack. Now let's see how redundancy and engagement play a role in robustness in inference method. We run an experiment on synthetic dataset and inject 20% malicious answers to the data. As it's shown, with increasing redundancy, it's harder for adversaries to reduce the accuracy. However, worker engagement had no significant impact on the accuracy. To see the impact of disguise on accuracy of methods, we vary the disguise level for methods. And for methods such as majority voting that doesn't have any attacker recognition, disguising only boosts their accuracy. For more robust methods, as disguise increases slightly, the algorithm fails to identify adversaries, leading to the success of the attack. However, as disguise further increases, the accuracy goes up. As it's shown in targeted attack, the general trend is that by increasing the number of attackers, the overall accuracy of the system increased, but accuracy of targeted task is decreased. In previous result, we can see that DS and BCC are most robust against untargeted attacks. However, in here, these two methods are more susceptible to targeted attack. and LAS is more robust against targeted attack. The attack susceptibility is measured as the opposite of AUC. A more robust method should have a lower susceptibility across both dimensions. To compare methods along two dimensions and to better identify the optimal methods, we can use skyline. It means the method that is not dominated by other methods, it's less susceptible. The reported value in these figures are calculated based on an average over the interval of malicious workers and all databases. Among direct computation methods, MVSoft is more robust than MV since its modeling of worker reliability. Among optimization methods, MVHard is more robust than PM just only for targeted heuristic-based attack. Among PGM methods, DS dominates BCC under heuristic-based attack. However, under optimization-based attack, BCC dominates DS, and it might be because of the nature of optimization attack that attackers collude with each other to come up with a better malicious and with a strategical malicious answers. And in neural network 1, the LAS dominates all others in all attacks except having a slightly higher susceptibility than DS in untargeted heuristic-based attacks. Let's conclude my talk and talk about the future work. So, in the crowdsourcing system, we can see that with the higher redundancy of answers, these systems are more robust. Also, we can see that the optimization-based attack is more effective compared to heuristic-based one. And among all the methods, LAS and DS provide a better performance. For future works, we can think about these three approaches. The first one is that build a more robust truth inference method, while existing methods provide certain level of resistance to data poisoning attack, but it remains an open question whether we can build the system to be more robust or not. Also, semi-supervised approach may help provide resilience to attacks, within which ground truth and workers answer for heuristical attacks tasks can be used for training the system. Our study is focused on just fixed set of workers and tasks. However, in practice, the worker could join and leave the system as they wish. They could also alter their behavior dynamically in a strategic way to maximize the attack effect. Understanding the impact of such behaviors and building robust systems in a dynamic setting is also an important direction. I wanted to conclude my talk and thank you for your attention. And if you have any question or comments, I will see you at the conference. Thank you.